For this problem, we want to write the augmented matrix that corresponds to the given system of equations. Here we have our system of equations. Before we want to write the augmented matrix, we first want to make sure that all our equations are in standard form. That is, we want all the variables to the left side of the equation, or the equal signs, and we want the constants on the right side. We also like to make sure that all our variables are lined up. If we look at this second equation here, we see that there's a constant 6 that needs to be moved over. So we're going to rewrite our system. First equation is fine. We're going to rewrite that. 4x minus 5y plus z equals 0. In our second equation, we're going to write negative 2x minus y. And there's no z term, so we'll leave that space there. We're going to subtract 6 from both sides, so we'll have minus 25. This third equation is okay. We're just going to rewrite that. X plus 5y minus 5z equals 10. Now we have each of the variables lined up. All the constants are on the right-hand side. So we can go ahead and write our augmented matrix now. The augmented matrix will really contain two parts. We're going to have one part that is made up of the coefficients of the variables, and then we have a second part here that's going to be made up of the right-hand side, or these constants. What I want to do is write all the coefficients for x in one column in our matrix. We're going to write all the coefficients for y in a second column. We're going to write all the coefficients for z in the third column. And then here we're going to write our right-hand side, which is the constant in our equation. So here we get 4, negative 5, 1, there's this implied coefficient of 1, and the right-hand side is 0. For our next equation, we'll have negative 2, negative 1. There's no z term, so we're going to use 0 as our coefficient. And the right-hand side is negative 25. Then we get 1, again the implied 1 there, 5, negative 5, and 10. And we have our augmented matrix.